Hello, in this video, I am going to discuss one of the IGCSE Physics past year paper, which is May-June 2024, paper 42. So let us get started. Now, the first question, wow, it is about a load is suspended from a thread. The vertical force on the thread due to the load is 0.75 Newton. Calculate the mass of the load. So if you're about to calculate the mass of the load and the force is being given, all you need to remember is W equals mg or F equals mg. So F is given, so all you need to do is just to sub in 0.75. M is the symbol of mass, which you are required to find. And G, I want you to remember one thing, which is super duper important. Start from 2023, the value of acceleration of free fall or the value of G has already been changed to 9.8 meter per second square. So you have to be extra careful, replace it with 9.8. It is no longer 10, right? So m times 9.8. So all you need to do, move the numbers to the left-hand side, 0.75 divided by 9.8. You should be getting 0.0765. What is the unit of mass? It is in kilogram. So before you fill in the blank, you got to make sure that your answer must be in minimum two significant figures, maximum three significant figures. So I'm going to put it in terms of two significant figures, which is 0.77 kilogram. Make sure that you put it in terms of 2 to 3 significant figures and make sure that the unit is correct. Now, B, Fig 1.1 shows the load suspended from the thread. A wire is attached to the load at point X and pulled horizontally to the right. Tension in the horizontal wire is 1.2 Newton. By drawing scale diagram or by calculation, determine the magnitude of the resultant of the force at X due to the load and due to the tension in the wire and the direction of the resultant relative to the vertical direction. Show your working. So there are two ways to do this. If you want to draw a scale diagram, so you need to come up with the scale that you're using. So there are two forces here. One is the weight of the load, and the other one is the tension of the wire, right? So look at the magnitude of the resultant force as at X due to the load and due to the tension in the wire, right? So the tension in the horizontal wire. So this wire is being pulled to the right, yeah, with 1.2 Newton. And of course, there is the weight of the load, which is already been given, which is 0.75 Newton. So if you want to do a scale diagram, you have to come up with the scale like 1 cm is equal to how many Newton. And then all you need to do is just to draw your vector triangle, which is the easiest one. Draw your vector triangle and then you draw your resultant force. Right? When you draw your resultant force, just use your ruler, measure, and convert it back to Newton. And job is done. But since I'm drawing it out digitally here instead of measuring, I am going to draw the diagram for you. So if you draw a scale diagram, this is what we expect to see, right? Whenever you draw a scale diagram, right, there are two vector diagrams that you can draw. One is called vector triangle. The other one is called parallelogram method. So for this question, I would strongly suggest you to use vector triangle because it saves a lot of your time. So to use a vector triangle, you just need to remember one rule. That rule is called tip to tail rule. What do I mean by tip to tail rule? Now, look at how I draw it. First, come up with the scale. Maybe 1 cm is equal to 1 Newton maybe, or maybe lesser than that. So you draw, measure, right? So measure I draw the weight. I draw the weight of the load first, which is going downwards, which is 0.75 Newton. So what do I mean by tip to tail rule. The tip, you just remember the arrow. Whenever you draw a vector, an arrow must be drawn because vector represents direction. So the tip of the arrow must be combined or must be joined with the tail of the second vector. So I join, this is what we call tip to tail rule. Join with the second vector, which is 1.2 Newton, and the resultant, you have to start from the first vector that you drew, which is from the tail of the first vector, all the way down to meet the tip of the second vector. That is how you are supposed to draw. So this green color line here, I use different color to represent it. So this green color line here represents my resultant vector or resultant force. So since I didn't draw my scale diagram, therefore I need to perform calculation. So this calculation is related to Pythagoras theorem. So do you still remember Pythagoras theorem? You are supposed to find resultant forces here. F resultant. Whenever you draw a vector for resultant force, please make sure that you put two arrows. Right, so this resultant force is a hypotenuse. So how do I do? Resultant force is equal to square root. This is a math. 0.75 square plus 1.2 square. Let your calculator solve it. And I got 1.42 Newton, three significant figures, remember? So the magnitude of my resultant force is 1.42 Newton. And I'm done with that. Right? And the second part, the direction of the resultant relative to the vertical direction. So I have already highlighted my resultant and which is the direction that is relative to vertical. Which one is vertical? This is called vertical direction. So the direction is actually the angle. So the angle is actually this angle over here that you have to draw. So since I didn't draw my scale diagram again, so I am going to use the Pythagoras theorem again. Wow, this guy is very, very useful, the theorem. So I'm going to use tangent theta is equal to, tangent is opposite over adjacent. So it is 1.2 divided by 0.75. Therefore, theta is equal to arctangent 1.2 divided by 0.75. And my answer is 58 degrees. So I just fill in the blank, 58 degrees. That's all. Now see, forces may produce changes in the size and the shape of an object. State two other changes that forces may produce. What are the two changes? Maybe force can change your direction. You are moving forward. Let's say the ball is being kicked forward and somebody, right, your friend may be kicking the ball to horizontally. So it could change the direction of the ball. Kicking is a force, right? So I will say could cause the change in direction and force. Whenever an object, like let's say the ball is rolling in front of me and I think that I feel like kicking the ball, so I kick the ball forward. What happens to the ball? The ball will move even faster. That is called accelerating the object. So accelerates object. That's all. Now, second question, define acceleration. Now, if you want to define acceleration by using equation A is equal to V minus U over T, don't just stop just right there. You have to put a comma here and explain where A is equal to acceleration, V is equal to final velocity, U is equal to initial velocity, and T is equal to time. Then only you are eligible for that 1 mark. But if they ask me to define acceleration, I would rather define it using word, rate of change of velocity, or you can say change in velocity per time taken, not a problem. That is how I define my acceleration right here. Now B, a train has a total mass of 520,000 kilogram. The train accelerates at 1.1 meter per second square. First part, calculate the time taken for the train to increase its speed from 15 meter per second to 28 meter per second. See the equation that I have already wrote down? I am definitely going to use that equation. So A is equal to V minus U over T. I'm not going to use that mass just yet. So acceleration, I just fill in 1.1 And the final velocity, because the train increases the speed. So this is initial velocity. This is the final velocity. You just take 28 minus 15 divided by time taken. So make sure that your time as the subject. So the time is 28 minus 15 divide 1.1, and the time taken is 11.8 second or 12 second. So I put 11.8 second, three significant figures, or you can put it in 12 second, which is two significant figures. Now the second part, calculate the force required to produce an acceleration of 1.1 meter per second square for this train. So when you are asked to calculate force, F ma, just use F ma. F is the force that you are calculating. M is the mass, which is 520,000. 1, 2, 3. Yes, it is correct. Times the acceleration, which is 1.1. So I got 572,000 Newton. So my answer is 572,000 Newton. Now the second part, the train uses electric motors. Explain why the force on the train due to the motor is greater than the value calculated. You know, when this is about train, when this is about electric motor, there are a lot of stuff because train, yeah, is constructed using a lot of things here. And then when the energy, so you have, I explain in terms of energies here because I need a larger force because the force is not to move just the train and the motor, but the force is needed to overcome some other resistive forces like maybe air resistance, maybe frictional force, right? So I say, okay, extra or additional force, extra force needed to overcome resistive forces. If you want to explain resistive forces, okay, such as resistance, drag force, resistance, and maybe frictional force. So that's all. Now the next one, question number 3. A student drops a heavy ball from a vertical height of 1.8 meter above the ground. The ball then falls to the ground. It does not bounce after hitting the ground. It just stay there. So A, describe the transfers of energy of the ball between stores from which the ball begins to fall to when it reaches the ground. So ball drop from a vertical height. When you see there's a vertical height, this is, you just imagine, or you can draw, not a problem. This is a ball. So the height here is 1.8 meter above the ground. So when the ball is given a height, the ball has initial energy, which is gravitational potential energy. Just bear this in mind, it's very important. So I will say initial energy of ball is gravitational potential energy, right? So when the ball is moving, when the ball is falling, what happens is that, okay, I explain when ball falls, gravitational potential energy is converted to kinetic energy because when the ball is falling, the ball has to move. So it is converted to kinetic energy of the ball. And when the ball hits the ground, kinetic energy of the ball, kinetic energy transfer, or you can say converted. Okay, let me say converted, easier for me. Okay, is converted to, I say, internal energy. Or if you want to, if you don't feel like putting internal energy, you can put it as thermal energy or heat. Because the ball stop hits the ground and then it is being converted to internal energy of the ball or the heat or the thermal energy of the ball. So that's the answer. Now B, Calculate the maximum speed of the ball. Ignore air resistance. When you ignore air resistance, things are getting easier for you. So think calculation would not be that complicated. So when you calculate what is the maximum speed, always remember principle of conservation of energy can be applied here. So I am going to, since I have already drawn the diagrams, initial energy of the ball is GPE, which is converted to kinetic energy of the ball. Because when the ball hits the ground and the ball does not roll and the ball does not move, so it does not give rise to kinetic energy. GPE is equal to mgh, which kinetic energy is half mv squared. So you could see m and m can be cancelled here. G, again, I have to remind you, the G value is 9.8, the h is 1.8 meter, which was given, and which is half v squared here. Just make v as a subject. V is equal to 2 times 9.8 times 1.8, and you square root the whole thing, and the speed that you get is 5.94 meter per second. Remember, the unit of speed is meter per second. So you can put your answers 5.9 meter per second or 5.94 meter per second, which is 3 significant figures. Question number 4, which is quite popular nowadays, state 2 ways that evaporation differs from boiling. I said that evaporation, I will highlight the keywords here, just here. Evaporation occurs at the surface of the liquid. So because evaporation can only occur at the surface, evaporation, surface, whereas boiling throughout the whole liquid. The second difference way which evaporation differs from boiling is that evaporation can occur at any temperatures, whereas boiling must occur at only fixed temperature. We call it as boiling point. B, Fig 4.1 shows part of the container used to store a mixture of liquid and gaseous oxygen. The temperature of the liquid oxygen is negative 160 degrees Celsius. Determine the temperature of the liquid oxygen in Kelvin. So there's a relationship between degrees Celsius and Kelvin. And if you still remember, to convert degrees Celsius to Kelvin, you just add 273. So you get 113 Kelvin, though that is the answer. The second part, the container is made of steel, and there's a vacuum between the inner and the outer walls. The outer wall of the container is at room temperature. So state 2 methods of thermal energy transfer that a vacuum prevents. First of all, there are three methods of how the thermal energy can be transferred. One is called conduction. The other one is called convection, circulation of the fluids. And the third one is called radiation. So since they asked us to state 2 of the methods, I cannot state radiation because radiation can transfer through vacuum. Yeah, all you need to do, okay, let me give you one example. Why do I say that radiation can transfer in vacuum? Imagine there's a sun and we are on the earth, right? Between the sun and the earth, there's nothing. It is called vacuum or free space, but still we can feel the heat from the sun. That is radiation, right? So the 2 methods are conduction and convection. Now, C, describe in terms of particles how a gas exerts a pressure on the walls of its container. Now, I just want to tell you that this type of question is super duper important. How the gas exert pressure, that is super duper important. All this while, the marks given is always 3 marks. Now, I will explain in a more detailed manner. I said that air particles, because this is about gas, or you can say gas particles. Now let me change that to gas, easier. Gas particles. Gas particles are moving in random directions. So they move in all directions. So what to do when they move in random direction? Remember one of my YouTube video, I talk about the command of the question, the words, command word from the question. When it is about description, you are asked to describe something. So you have to describe from A to Z, right? So I said that gas particles are moving in random directions. So due to the random direction, right, the gas particles collide with themselves and walls of container all the time. So due to the collision, what happened, right? I would say, right? Collision are elastic. What do I mean by elastic collision? That means that when a gas particle is colliding with the wall of the container or with themselves, they do not stick together. So they will rebound off. They rebound with the same speed, right? Okay. There is a change in momentum. Still remember what is momentum? It is due to collision, right? A change in momentum, that means final momentum minus initial momentum, right? So what to do with that? Rate of change of momentum gives rise to force. See that? This is Newton's second law, right? And then what to do? Force and pressure. So pressure equals force per surface area of container or the inner wall of the container. That's it. Now, the next one, question number 5. Fig 5.1 shows a ray of yellow light incident on glass prism A, B, and C. A, explain why the ray does not change direction when it enters the prism at face AB. You could see that when the yellow light is entering the ray at the face AB. I want you to see carefully here. So when it enters AB, ray and AB, don't you think that the ray is making 90 degrees, enter the face AB at 90 degrees? So the ray enters in the direction of normal. What is normal again? Normal is just an imaginary line you draw on the surface of the glass prism. Is imaginary line which is perpendicular to the face AB in this case. So I said that, okay, ray enters AB along the direction of normal. So what to do with why ray enter the face AB along the direction of normal and the direction does not change? It is due to incident angle equals to 0 degree. So that is why the direction would just go straight. Now B, the critical angle for the glass is 42 degrees. Calculate the refractive index of the glass. Since the critical angle is given, I would strongly suggest you to use this equation. N is equal to 1 over sine C. What is C? C represents critical angle and N represents refractive index. What is critical angle? Critical angle is the angle of incidence that causes the light to be refracted at 90 degrees between the two surfaces, 90 degrees, when the light ray travels from denser medium to less dense medium. That is critical angle. So why do I have 1 over sine C? Because when refracted angle is at 90 degrees, sine 90 degrees is equal to 1. That is why you get a 1 here. So N is equal to 1 over sine 42 degrees. N is equal to 1.49. 1.49 is my answer. There's no unit of N. Now on Fig 5.1, continue the path of the light through the prism and after it leaves the prism. This is how I do when it enters. So you have to bring protractor with you, measure this angle. So it causes internal, if the angle is larger than 42 degrees, which is proven to be larger than 42 degrees when I do it, so total internal reflection will occur. So incident angle must be equal to reflected angle. So you have to measure that these two angles are the same. So that angles must be measured from normal. So you have to continue. Arrows are very important as well. So draw a normal here where it hits the surface BC, draw a normal, measure the angle. And then after that, total internal reflection occur, measure the same angle reflected. And then towards the face AC, just draw a normal line. This is what we call incident angle inside the denser medium. And when the light ray travels from denser to less dense medium, it will be refracted away from normal. So this is called refracted angle away. So I need to see this ray. Now, the next one, see internet data can be transferred using infrared waves in optical fibers. State two advantages of using optical fibers to transmit data. Optical fibers is actually a fibers full of pure glass, like thickness is like the strain of your hair, right? Contained inside the fiber. So what is the advantages of using optical fiber? Because optical fiber using infrared. Infrared is one of the electromagnetic waves which travels with the speed of light in vacuum as well as in air. So the speed of your Wi-Fi, don't you think so? The speed of your internet will be very fast as compared to before. I would say that it is more secure and more information or more data can be transmitted at one time. Yeah, that's it. Number six, a sound wave travels through air. Fig 6.1 shows a pressure time graph for the air at one place. On Fig 6.1, label one point C to indicate compression. Look at the graph. This is the graph of pressure against time. It is not displacement against time. So when pressure against time, you have to think about sound waves is a longitudinal waves, which consists of a series of compression and rarefaction. When it is about compression, right? What is the definition of compression? What is meant by compression? Compression meaning to say that all the air particles are coming closer to each other. So at the center of compression, the center particle, air particle cannot move because it will be compressed in two directions. So at the center of compression, just imagine yourself as a human. I don't like people to come close to me when it is too close and I don't have the freedom to move. I feel that it is quite stressed out, so pressurized, right? So at the center of compression, actually the pressure is maximum. So you put C here. What about rarefaction? Rarefaction means that all the particles are moving away from each other, right? So at the center of rarefaction, there is no air particles, so it's freedom, don't you think so? So at the center of rarefaction, because it has least pressure because I feel so relaxed, nothing to disturb me. So at the center of rarefaction, pressure is the lowest one. So R is here, refraction. Okay, now see the next one. Explain why this graph cannot be used to find the wavelength of the sound wave. Remember, how do we use the graph to find the wavelength? I want you to see this very, very closely. Look at the x-axis. It is time. So when the x-axis is time, we can just use this graph to find the period and to calculate the frequency. How do I find wavelength? There's no way I can find my wavelength. Don't you think so? Right. So I would say that, okay, x-axis is time. Okay. I will explain further. In order to find wavelength, x-axis must be distance. Remember that. Now, the third one, the sound becomes louder and lower pitch. State what happens to the amplitude of the sound. Louder, right? Louder, the amplitude is increasing. When the sound, okay, I want you to hear this carefully. High pitch means lower pitch means low key, right? So the frequency of the sound decreases when the pitch is lower. So that's it. The next one, B. A sound of frequency 13 kilohertz is transmitted through water. The speed of sound in water is 1,500 meters per second. Calculate the wavelength of this sound in water. So all you need to do is just to write down the equation of the wave. Wave speed is equal to frequency multiplied by the wavelength. Now, the wave speed is given as 1,500. Frequency is 13 kilo. Remember, one of the prefixes which carries the value of 1,000 or 10 to the power of 3 times lambda. Make sure that lambda is equal to 1500 divide 13000 and your wavelength is 0.12 meter. Fill in the blank, 0.12 meter. That's it. And state the approximate speed of sound in air. So the speed of sound in air that I state is 330 meter per second. It could be 340 meter per second, not a problem. Now the next one. Number 7A, figure 7.1 shows 3 bars of steel A, B, and C. A, B, C, a student is given the 3 pieces of steel. 2 of the pieces are magnetized and 1 piece is unmagnetized. Steel, remember, steel is a magnetic material, right? Describe and explain how the student determines which piece is unmagnetized using only 3 pieces of steel. Now, I state one by one. I do the experiment one by one. I say I bring steel A, right, close to steel B first. Now, steel A is here. Okay, make sure that this is steel A close to B, then steel A is here. Then bring steel A close to C and steel A close to C again. So you bring steel A close to 2 ends of B and C. See what happened. After that, repeat the same experiment. Bring steel B close to 2 ends of A and bring steel B close to 2 ends of C. And after that, bring steel C close to 2 ends of A, bring steel C close to 2 ends of B. Right? So why do I do that? Let me explain here. Right? So if both steels are they are magnetized. You know magnet, they will attract and they will repel. So they can attract each other at one end and repel each other at the other end. But if one of the steel is unmagnetized, but steel is a magnetic material. So all the magnetic materials will be attracted to magnet. So if one of the steel is being unmagnetized, then the unmagnetized steel will be attracted to magnet at both ends. So that's the explanation. Now B, figure 7.2 shows a circuit diagram of a step-down transformer. Now, the mains voltage supplied to the transformer is 240 volt. The output power of the transformer is 45 watt. Transformer is 100% efficient. What do they mean by 100% efficient? If you want to know more, one of my YouTube videos discuss about transformer. You can check on that. Right? Calculate the input current to the transformer. So, input current, 100%. Let me review a little bit. 100% efficient, meaning to say that the input power of the transformer must be equal to the output power of the transformer. Input power is equal to IV. I input, V input is equal to I output, V output, IV. Now you just need to find the input current. So the input voltage is given as 240. And the output power is given, so I straight away put 45. Now, input current is equal to 45 divided by 240. The answer is 0.19 ampere. So 0.19 ampere is my answer. Now, draw a label diagram of a step-down transformer. On the labels, state a suitable material for each of the components. So this is my step-down transformer. You have to show that the primary coil has more number of turns compared to the secondary coil. How do you detect which is the primary coil? The one that is connected to AC supply is the primary coil. So I label the material. These are soft iron cores and this primary coil, and the secondary coil they are using copper wires. Why do we use copper wire? Because copper wire is a better conductor with less resistance. And I connect to voltmeter. You can connect to light bulb. You can connect to resistor. Not a problem. Now, number 8. Fig 8.1 shows the circuit. The circuit is designed to switch on a night light when the surroundings are dark. On Fig 8.1, draw the circuit symbol for a voltmeter used to measure the potential difference, PD, across the light-dependent resistor. Now you need to know which is LDR, which is LED. LDR, light-dependent resistor. So the arrow represents the light. Light must be directed to LDR. So this is the one. This is called LDR. LED is light-emitting resistor. It emits the light. So the arrow must be coming out from it because it is emitting the light. Right? The second part, the surroundings change from light to dark. State the effect of this change on the resistance of the LDR. So LDR works like this. When there is a light, resistance of the LDR is low. When it is in darkness, resistance of the LDR would increase. So the answer is change to light to dark, so the resistance increases. State and explain the effect of this change on the PD across the light-emitting diode. What to do with LED. Look at LED and LDR. Okay, I better label this. This is LDR. This is LED. LED and LDR are being connected in parallel. So, right, what happens here is that when the PD across, when the resistance across LDR increases, right? Resistance V equals to IR. So since the LED and LDR are being connected in series, I across LED is the same as I across LDR. That is why V is directly proportional to the resistance. When the resistance of the LDR increases, I would say the PD. I will use PD because they have already explained the symbol of PD. Across LDR and LED increases. I cannot use symbol, I'm very sorry. I need to write increases. LDR and LED share the same PD. Is that okay? Oh yeah, it's not current, I'm sorry. So it is actually the L, okay, so using V across LDR. This is not current. Remember, this is potential difference because LED and LDR are connected in parallel. So the potential difference across LDR is equal to the potential difference across LED. So since resistance V is directly proportional to R, PD across the LDR would increase due to the resistance of the LDR is increasing. Right? So therefore, it will affect the PD across LED as well because they share the same PD. Right? Now, I will say, explain. Why do I say the PD across LED will also increase? I better write down. Okay, this one is PD across LED. Change this. PD across LED increases. Now, as LED and LDR are connected in parallel, V across LED is equal to V across LDR. That's it. Now the next one, B, Fig 8.2 shows another circuit. Lamps A and B are identical filament lamps. The current supplied by the power supply is 0.5 ampere. Calculate the resistance of lamp A. Lamp A and B are identical lamps. Identical lamps meaning to say that they have the same resistances. Current supplied by the power supply is 0.5 ampere. Do you see a junction here where the current splits? Since these two lamps are identical, so they have the same resistances, therefore the current will split to half, 0.25 ampere and 0.25 ampere. Now calculate the resistance of lamp A. So I just use V equal to IR. V is 240. Why? Because lamp A and B are connected in parallel, so they share the same potential difference. I is 0.25 and calculate R. R is equal to 240 divided by 0.25, which is equal to 960 ohm. So 960 ohm is the answer. Now the next one, number 9. A, radioactive isotopes that emit ionizing radiation are used in hospitals. First one, state and explain 2 safety precautions necessary for the use of these isotopes in medical procedure. Okay, I said that safety procedure one, like X-ray, right? We have to limit the exposure time. Why? Because I want to decrease the amount of radiation absorbed by my body, which could cause mutation to my cell at the end of time, right? And safety precaution two, I say use shielding in handling radioactive isotope because shielding will actually prevent the isotope from penetrating towards our body. Now, the second one, okay, give two reasons why alpha emitters are not used as a radioactive tracer inside the body. I would say that because alpha particles are big particles and they could be stopped by few sheets of paper, right? Our body is actually thicker than the paper. So it doesn't serve any purposes. That is why I say, okay, alpha particles cannot penetrate into the body. So it serves no purposes. Second is that alpha particles have a very strong ionizing power. So it could ionize the air particles. It doesn't serve any purposes, but still we conduct the experiment in air. So it could ionize the air particles, right, to cause danger to our health. So I would say alpha particles have a strong ionizing power to ionize surrounding air particles. Okay, let me erase this one. Hypo ionizing. Okay, ionizing. Yeah, that's it. B, sodium 24 is an isotope of sodium Na that has a proton number of 11 and nucleon number of 24. Sodium 24 decays by emission of beta particle to form an isotope of magnesium. Use nuclide notation to write down the nuclide equation for this decay. So sodium 24, they have already give you 24, proton number is 11, Na decay to form beta particle, beta negative to form magnesium. So to check magnesium, so you balance the nucleon number. 24 is equal to 0 plus 24. And 11 is equal to negative 1 plus 12. That's it. Now, number 10, the solar system includes the sun and planets, which is true. State two other types of natural objects that orbit the sun. So the natural object are, okay, comets as well as asteroid. The asteroid belt, remember, between the Mars and Jupiter's, they are natural objects. Now, B, state the shape of the orbits of the planet. So the orbit of the planets are elliptical. It is not circular. But when we do perform our calculation, we assume that the orbits are circular to simplify our calculations, actually. Now see, Fig 10.1 shows the orbit of an object around the sun. At point A, the object is closest to the sun. This is the orbit of the comets, don't you think? At point B, the object is furthest away from the sun. State and explain the energy transfer as the object travels from point A to point B. So furthest and closest. I would say that when it is at the closest one, it has the highest kinetic energy. So I would say kinetic energy converted to potential energy at point B. Right? Explanation is that when at point A, because point A, the object is closer to the sun, gravitational force is the strongest at A. Okay, and then which okay. Or you can say explanation why energy transfer. I don't want to talk about the force because this is just 2 marks. So I will say principle of conservation of energy. Okay. Uh, total energy is conserved. Total energy is conserved between kinetic energy and potential energy. That's it. Now, D, Jupiter is 7.8 times 10 to the power 11 meter from the sun. The speed of light in vacuum is 3 times 10 to the power of 8 meter per second. Calculate the time taken for the light from the sun to reach Jupiter. So I'm going to use the basic thing, kinematics. Speed is equal to distance over time. Speed is 3 times 10 to the power 8. The distance is 7.8 times 10 to the power 11. And this is time. Make time as the subject. So it is 7.8 times 10 to the power 11 divided by 3 times 10 to the power 8. I got 2,600 seconds. So 2,600 seconds is my answer. And number 11, name the galaxy that contains the sun. It is called Milky Way. B, light observed from distant galaxies is redshifted. State the theory of the universe that this observation supports. It actually supported Big Bang theory. So you remember? Now, C, cosmic microwave background radiation, CMBR, is observed at all points in space. State when this radiation was produced. This radiation is actually being produced like quite some times ago, actually. So it is when the universe, not exact time, yeah, universe is firstly being formed. Now, the second part, explain why this radiation is now in the microwave region of the electromagnetic spectrum. Why? Because it has already cooled down actually, and then it gives out shorter wavelength, and the universe is actually universe has universe has expanded. Okay, and the wavelength, okay, given out is in microwave region. Right? It has already cooled down. Last time used to be very, very hot when it firstly formed, and then it gives out the wavelength in terms of microwave. So that's the end of the discussion. If you feel that you want the PDF answer, just comment below. And please do subscribe to my YouTube video. And thank you very much for watching. See you again in my next video. Bye.